This video is on absolute value functions. The basic form of an absolute value function, which is f of x equals the absolute value of x. The absolute value is commonly thought of as providing the distance the number is from 0 on the number line. And algebraically, for whatever the input value is, the output is a value without regard to sign. In other words, the output is always positive when it's an absolute value. When we solve absolute value, I don't know how to say this. All right. When we're solving absolute value, we're going to have a positive answer and a negative answer, because what we're looking for is what is in the absolute value. What am I taking the absolute value of that's going to give me a positive 12? Well, I can take the absolute value of positive 12 and get a positive 12. Or I can take the absolute value, of negative 12 and get a positive 12. So we're going to see what x is. We're going to find the value of x to determine what a positive 12 is. So I'm going to drop the absolute value signs and set it equal to positive 12. And I'm going to solve for x in a minute. And then I'm going to take it, same function, and set it equal to negative 12. Because the 5 minus 3x is what's inside. And if it equals negative 12, then it's still a positive 12 when I take the absolute value of it. So I'm going to solve, or subtract 5. So negative 3x, 12 minus 5 is 7. Divide by negative 3, x is negative 7/3. Then I'll do the same thing over here. I subtract 5. Negative 3x is negative 17. Divide by negative 3. X is a positive 17/3, because negative divided by negative is positive. So x can either equal negative 7/3 or positive 17/3. If I put the negative 7/3 in here, it's going to give me a positive 12. If I put this positive 17/3 in here, it will give me a negative 12. And still, the absolute value is still positive 12. Looking at B, its absolute value equals an absolute value. So we choose one of them to make either positive or negative. And I'm going to make the absolute value of x plus 6 my answer. So again, I'm going to set it up 4x minus 3, drop the absolute value signs, and it's going to equal the positive x plus 6. Then I'm also going to work it for the negative, and I'm going to do a negative times x plus 6, because it's the opposite of that. So let's solve the first one. So I'm going to subtract x from both sides. So 3x minus 3 equals 6. Add 3. 3x equals 9. Divide by 3. X equals a positive 3. So x can equal a positive 3. I'm going to distribute the negative here and get 4x minus 3 equals a negative x minus 6. And we'll solve for x. I want to add x to both sides. 4x and 1x is 5x minus 3 equals negative 6. Add 3 to both sides. 5x equals negative 3. Divide by 5. X equals a negative 3/5. So x can equal a negative 3/5 or x can equal 3. So that's solving the absolute value. And we're going to use solving the absolute value to find the zeros of the absolute value function. So if you want to find the zeros of the absolute value function, we're going to use it to graph. If we were to graph this function on a coordinate graph, the place where the function crosses the x-axis is the x-intercepts, just like any other graph we would do. It's also known as the zeros of the function. So if you're asked for the zeros, you're actually finding the x-intercepts. Alright, and so we're going to solve for the zeros of the function algebraically. But the first thing we have to do is we have to get the absolute value by itself. We can't solve it if it's got something tagged onto the outside. So as I've already done this, I'm going to add 7 to both sides. Then 7 equals my absolute value. This is what I'm going to use to find my x-intercepts, or my zeros. So since it's equals, I can set it up as 4x plus 1 equals a positive 7. And then I can do 4x plus 1 equals a negative 7. Again, I'm looking for what's going to be in this absolute value sign, or within the absolute values, whatever this number is, and if I take the absolute value of it to get 7. So I'm going to, just like we did in example 1, I'm going to find x. So I'm going to subtract 1 from both sides. So 4x equals 6, because that's a negative. Divide by 4. X equals 6/4. We want to reduce that. We've always got to reduce our fractions. So 2 goes into both of them. That's 3/2. So I'm going to do the same thing to the negative. I'm going to subtract 1. So 4x equals negative 8. Divide by 4. X equals negative 2. So my zeros are 3/2 and negative 2. If I wanted to write it as x-intercepts, then we have to write it as an ordered pair. So 3/2 and 0, and negative 2 and 0, because the x-intercepts is where it crosses the x-axis. So this is the end of part 1.